Okay, we're going to jump back into chi-square test. So today we're going to do the chi-square test for homogeneity. So the difference on this one really is what we did before, and let me kind of bring up this screen so we can kind of look at the notes. Okay, so what we did before, we did this thing called the chi-squared goodness of fit test. So we had a chi-squared goodness of fit test. And what that was realistically, we just had one sample and one variable. Okay, and so what we were trying to do is like the M&M thing. We were trying to prove if M&M's claim was true. What we had is a one-way table. We had, the colors. We had orange and green and blue and red and brown and yellow. So we had 1, 2, 3, 4, 5, 6. We had 6 categories. We were trying to say, hey, M&M claims something. So they had a claim, and we had an observation. And then we figured out what an expected number would be. And then we compared that observed to the expected. So that was our chi-square goodness of fit. A chi-square test for homogeneity is basically the following. I'm going to take 2 or more samples. I'm going to take a few samples, and I'm going to try and prove if they're different based upon the categories within. So in this case, we're going to take a look at this question. Social scientist selects a random sample of 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors from various high schools across the state of Kentucky. Each student was asked if they preferred in-person or remote learning. So what we're going to do is when we look at this, we are going to say these are individual samples. So this is kind of like sample 1, this is sample 2, this is sample 3, and this is sample 4. We're going to see if there's any difference between those years, between freshman, sophomore, junior, senior. So there's 4 different samples. And there's a couple different things. We're trying to determine if it's remote or in person. So we're still going to go through that same process. So let me kind of show you the phantom. So P is going to be the true proportion of, and in this case, learning types or learning methods by grade. So we were trying to figure out the true proportional learning methods by grade. So that's kind of like our P. The next thing we're going to do is we're going to have our hypotheses. That's our null and null alternative. Here's our null. It's always going to be there is no difference between method of learning by grade level. That's the null hypothesis. The null hypothesis is there's no difference. The alternative, there is a difference. There is a difference between method of learning and grade level. Okay, so the way that this is going to work out is we're still going to go through that same process of A. So again, A is not on here, but what A is, and I'll kind of flip over here so we can look at it. We're going to go ahead and we're going to check those 3 assumptions. In this case, we're going to check random. We're going to check independent. And we're going to check large enough. So in this case, we're going to go back and look. It says we got a random sample. So in this case, we got random sample. So our samples are all random. We're going to check the 10n condition. And in this case, what we're going to do is we're going to do 10 times 25. That's 250. And it's actually 250 for all the different years. So what we're going to say is we're going to assume more than 250 freshmen, sophomores, juniors, seniors, and then large enough. And like with goodness of fit, our large enough is we want to really look and see that all of our expecteds are greater than 5. But realistically, the way we're going to think about it is that our smallest expected should be greater than or equal to 5. So here is where the calculator is going to become your friend. So what I'm going to do now is I'm going to put this data in the calculator. What I'm going to do is, and let me explain to you how you're going to do this. You're going to use the matrice function on your calculator. Some of you may learn this in Algebra 2. If not, I'm going to kind of walk you through it. It says matrix right here above the x to the -1 button, the x to the -1 button. So what you're going to do is you're going to do second, x to the -1 for matrix. You're going to arrow over to edit. You're going to edit A. And then what you're going to do is you're going to say, what size matrix? And the way it always works is it's rows by columns. So we have 2 rows. We have 4 columns. So now what I'm going to do is put the data in 3, 12, 14, 15, 22, 13, 11, and 10. Okay, this is one of these ones where what I'm going to do is I'm actually going to run the test and get the number that I need for this before I actually go to the process of where I would get it. So in this case, there's my matrix. I'm going to go to stat. I'm going to go to tests, and I'm going to arrow to letter C, which is chi-square test. The really good thing is if you put your observed in A, all you need to do is enter through this. And it's going to give you, we're going to come back to this. It's going to give us our chi-square statistic. It's going to give our p-value. It's going to give us our degree of freedom. We're going to come back to that in a minute, but what we really need is the expected. So what I'm going to do now is I'm going to go back to matrix. So second, x to the -1. And what's really nice is it created an expected matrix for me. So what I'm going to do is hit enter here. And what it's going to do is it's going to show me the expected matrix. This is what I would expect. So in this case, what I would expect is if everything was being equal, this would be 11, this would be 11, this would be 11, this would be 11, 14, 14, 14, 14. Okay, so now what I have is I have my 11s and my 14s. Those are all my expecteds. And what I would do is I'd write them up here. And what you're going to do is, this is the only time what you want to do is you want to show your calculation of how you got an expected. Okay. And the way that I do that is the following formula. It is roto times coto over toto. So it is your row total times your column total divided by your total. So in this case, I would take my row total, which would be 3, 15, 29, 34. I'd take 34 times 25. So again, my row total. So again, if I'm looking at this, how I got this a number, it's 34, because that's 3 plus 12 is 15, 29, 44. So that's 44 when I add across. It's 25 when I add down. So my row total is 44. My column total again was 25. And my total is 100. And if I go ahead into my calculator and I do 44 times 25 divided by 100, 44 divided by 25 divided by 100 gives me my 11. So I want to go ahead and show that. And this is going to be equal to 11. And that is freshman remote. In this case, 11 is greater than or equal to 5. Freshman remote is greater than or equal to 5. So I've met my large enough condition. How are you going to know what your expected? That's why you do it in the calculator. What you would do is you'd pick whichever one of these numbers here would be the smallest. I just picked the first 11 that I dealt with. So that's kind of different just to get used to. So now what I've done is I've done my checks. Now I can run my chi-squared. And the way chi-squared is calculated is chi-squared is calculated. So again, show the calculation for the expected count in remote senior. So again, let's just go over this again just to show how you get remote senior. So remote and senior right here. So again, if you want to look at that row total, the row total for remote row total is equal to 44. Senior column total is 25, and our total is 100. So if I wanted to get my expected remote senior, it's 44 times 25 divided by 100. That's how we get 11. So to get the chi-squared statistic, this is the formula. Chi-squared equals the sum of observed minus expected, that quantity squared, divided by expected. And this is on your formula sheet if you ever need it. You have your formula sheet, I got it right here. There's chi-squared right down there at the bottom. Observed minus expected squared divided by expected. And what I want to show you is I want to say we're going to do the first and the last. So in this case, this is the first, this is the last. We're going to do observed 3 minus expected 11 squared, 3 minus 11 squared, divided by 11, plus ... plus. We're going to jump down here. This is 10, and that's a bad 14, so we'll make that a little brighter. 10, 14. 10 minus 14 squared divided by 14. And we're going to go to the calculator. Like I said, the calculator has done most of the work for us. So we go down and run that test again so we can see it. We do stat, we do tests. We're going to do letter C. We're going to arrow through. We're going to collect or enter and calculate. And this is going to give me 14.61. So there's my chi-squared statistic, 14.61. I actually have my p-value. I'm going to go ahead and write that down too, just so I have it. It says that the p-value is 0.002. And now the thing is, let me talk about degrees of freedom. Degrees of freedom are equal to 3. Let me show you how we get degrees of freedom. Degree of freedom is going to be your number of rows minus 1 times your number of columns minus 1. So in this case, we have 2 rows minus 1 times 4 columns minus 1. That's 1 times 3. That's how I got a degree of freedom of 3. And what we're doing to get this p-value is we're comparing this test statistic to this degree of freedom. So in this case, if you look at this, that's a pretty low p-value. That p-value is less than the really realistic value of alpha we would deal with. That p-value, since our p-value of 0.002 is less than alpha of 0.05, we reject the null hypothesis. We reject the null hypothesis. There is evidence of a difference between method of learning and grade. There is a difference. And I mean, if you look at the numbers, you can kind of see where it really kind of jumps out at you. It looks like freshmen came back in person much more often than anything else. If you actually look at all the other ones, this is a pretty even split. It looked like more stayed remote junior and senior. So in this case, there is a difference. Who played the largest role? Normally, I'm going to tell you, much like with goodness of fit, they ask you who played the largest role. Realistically, if you want to know who played the largest role, what you want to do is look and see what numbers are the furthest apart. So if you kind of go and look at this, that and that probably played the largest role. And the reason, again, if you look, that's only 1 away from the expected, 1 away from the expected, 3 and 3, 4 and 4. These are 8 away. So really, this is the component that played the largest role. So if the question came up, who played the largest role? It looks like freshmen played the largest role in making that decision. Freshmen pretty much came back in person, so that kind of over influenced the results of this. So this is what's called the chi-squared test for homogeneity. Basically, again, we had multiple samples, 1, 2, 3, 4 samples. We were trying to see if those samples were the same. Did we really need to break it out by freshman, sophomore, junior, senior, or could we just leave them in one gigantic bucket? So that's a chi-squared test for homogeneity. It's the second, we only have 1 more test to go. The other test we have on the next class is our test for independence. We'll go over that on Thursday. And that'll kind of wrap up the year. We'll do a little kind of brief review of some stuff on Monday of next week. And what we'll be looking at is on Wednesday of next week is our first attempt at the final exam. It's going to be multiple choice, 40 questions. It'll be in class. You'll get a chance to kind of see what you know, what you don't know. And I will offer a second opportunity at that final exam on the 26th of April. So that following Tuesday after school, I will have it set up so you can come and do that as well. So hopefully that helped. Please ask questions if you have them.